Today I will talk about algorithmic technique from computational geometry, which is called a plane sweep algorithm. But before I move on to that problem, let's again start today's talk with a small puzzle. So what is the puzzle is that suppose in NIT Calicut is organizing a big seminar, and there are delegates from all over the world has came, and we have prepared, the NIT Calicut has prepared some kind of a juice or something which is very expensive. There are 100 glasses of juices prepared for the delegates. But unfortunately, it was informed to NIT Calicut that from RAW that there is a terrorist attack, and some of the terrorists had added some poison into one of these juice glasses. So everyone got scared that what to do. Then RAW says that don't worry, we are sending a military equipment which can find out that you put some sample on it, and it will tell you that whether that juice contains poison or not. So everyone said okay, chalo. But unfortunately, the equipment takes 10 minutes to check each glass. So 100 glasses, so it will, how much time it will take? 1000 minutes, right? We don't have that much amount of time. Prime Minister will be here in any moment. So the question is how to find out, how quickly we can find out that which glass contains the poison. We will make samples and test them. Okay. How to make samples? Small batches, like batches of 2 or maybe batches of 3. Batches of 10, then 10. So within 10 samples, what is his suggestion is make a batch of 10 samples each. So you have 10 samples. So you will take a little amount from each 10 and you test. You know that after 10 sampling, you know that which part of sample the poison contains. Then what we will do? I know that this 10, then again I will do it 5. So this 10, then again I will do how many? 5, then 1, 11, then 5. How do I find out from 5? Individual, more 5, 16. So 16 from 100 test we have reduced it to 16. Can we do better? We can bring it to, what is n here? So his suggestion is that we can bring the number of tests to log of 100. How? So I will take a sample of, I will divide everything into 2 groups. First 50 glasses, second 50 glasses. One test I will know. I will throw away 50. Second test I will throw away 25. Third test 13. Right? So how many tests altogether I will be needing? What is the recursion? Tn is the number of tests required equals to 1 plus 1 test T n by 2. One test was the number of tests required to find out whether there is a poison among the n by 2 glasses. Right? And how to solve this recurrence? This is equals to 1 plus T n by 4. Master theorem or common sense. This is equals to 1 plus T n by 2 to the power k, and where we will stop? When 2 to the power k equals to n. right? Take log in both the sides, what we will get? K equals to clear? Doubt? You have a doubt? Yes, no, maybe? Is it clear? What we are doing here, is it clear to you? Good. Can you please raise your hand if there is a doubt that why we need log n many comparison to find out which glass contains the poison. This is called a binary search. This is essentially what we are doing is a binary search. Now we can extend the same idea while searching for an integer in a sorted array. Suppose we have a sorted array, say we have 10, 16, 19, 24, 39, 56. This is my sorted array, and I am looking for whether element 16 is present in the array or not. I have given a sorted array which contains n elements, and I have to find out whether a given element is present in the array or not. So, what I will do? Binary search. How? I will go to the middle position of the array 24, check whether the given element which is 16 here is less than or greater than this 24 or not. It is less than, I will go into, I will only search into this side of the array. Next, maybe I have 3 elements, so I will go here, less than, greater than, equals to if found, done. Same recurrence will give you a log n bound for this searching. Clear? This is basic binary searching, and this is only possible because the array is sorted. We have saved time from order n to log n. How many glasses we have to check? 100 glasses in case of linear searching. There are 100 glasses, you have to check all 100 glasses in worst case. Now how many glasses we have to search? 7, right? So 100 into 10, from where we have reduced to 7 into 10, just little bit more than an hour. This is the amount of time we can save while doing the binary search. And this comes very often in all the like algorithmic computations. We use this fact very often, and we'll assume that you know about this. Okay. But what is the problem with this method? What is the problem with this method? Array has to be sorted. It may not be the case every time. For example, if you have, say, a dynamic data, what do I mean by dynamic data? The data is getting updated. In a regular time interval, some elements are coming inserted into the data, and there are some elements which are deleted. And there are queries coming in between. For example, do you do a Google search? The queries, Google queries are very frequent, but updates in the websites are not that frequent, but still there is a fair amount of updates going on around the internet every day. So we have to keep provision for that, and we are not able to spend a lot of time for that as well. So my next question to you is, can we create a data structure? What is a data structure? It is a way to store data which supports certain kind of operations. My next question to you is, can we create a data structure which will not only search in log n time, but also able to update and delete elements in log n time, or any modification can be done in log n time. So, what is a data structure again? This is like a storage, it can be an array, a linked list, a stack, queue, whatever, with 2 or 3 functions or maybe more functions which will use to modify, insert or delete or query those data that are present. That is what a data structure is. Question is, what kind of data structure we use? What about if we use simple array? How much time it will take to insert? Order 1. So, what is the plan? We will insert at the end, then we cannot do binary search, because then the list will not be sorted, so we will not be able to do binary search. For binary search, to log in query is the most important thing, because queries comes much frequently than the update instructions. So, if we keep it in an array, then we have to sort it, or you have to put in a sorted order. How much time it will take? If I have a sorted array, I want to insert another element into that in a sorted manner. Order of n, right? Can we improve? What about linked list? Everyone knows linked list? If you do not know, raise your hand. Okay. So, it is a linked structure. So, you have present in the last class, you were present in the last class. Who do not know linked list? Are you present in the last class? You have seen list, a similar kind of a structure. This is similar kind of a structure. So, how much time it will take to insert? Constant. Very good. We are trying to achieve constant, trying to achieve log n, but what we get is constant. Why constant? But how do you know that where to put the element? In linked list, how much time it will take to insert? Suppose I have a sorted array of linked list, and we want to insert one element in the sorted sequence. How much time it will take? Order of n. What about searching? Searching is order n. Insertion is also order n, because I have to search for the location in which I have to insert. Anything else? What about tree? Okay, first let us go step by step. What about a binary tree? Not even binary search tree. Okay, let us go to binary search tree. What is a binary search tree? What is a binary tree? Where the number of children at each node is at most 2, 0, 1 or 2. This is a binary tree. What is a binary search tree? So, every node, this is a tree. Where every node contains a number. For example, maybe it is 24, 19, 16, 18, this is 40, 56, 38. You look at any node, the value stored at its left subtree rooted at its left child is less than 24, and the values or the values rooted, the values present and at the subtree rooted at the right subtree is greater than 24. This is called a binary search tree. So, if I store all my data in a binary search tree, how much time it will take to insert or delete? If my tree is like this, then how much time? It is a binary search tree. I can make it like say 10, 5, this is 20, 30, 40, 50. I am looking for whether 55 is present here or not. How much time it will take? Not a good idea. But if this binary search tree is balanced, then how much time it will take? Log n. Suppose it is a complete balanced binary search tree. Then what is the height of this tree which contains n elements? Log n, right? This is 1 plus 2 plus 3, that is if there are k levels. So, it will take log n time. How much time to insert? Log n. So, we have to maintain kind of a balanced binary search tree. There are different balanced binary search trees which are not completely balanced, but the difference between height of two subtrees are not that much, and that can be done, that can be constructed in n log n time, which supports insert, delete and query operations in log n time. This you have to believe me. This is present in any standard textbook. This is the idea of a balanced searching or a balanced data structure which supports insert, delete and query operation in log n time. Are you with me? This is a complete data structure and it is very useful, you understand. It is a basic form of data structure which most of the known methods that uses, from database to information retrieval like Google searching to image processing, everyone uses this kind of data structures and very easy to implement, not much difficult. To open any standard textbook, you will find this. Please let me know if this concept is clear or not, because this is a very essential concept, because what I am going to teach next, I will use heavily that I know that a balanced binary search tree can be built in n log n time which supports operation in log n time. I will use that fact heavily. So, please let me know if this is clear to you or not. So, one thing I forgot to mention yesterday, that the slides are not, slide ideas are not mine. I have made these slides, but the slide ideas I have borrowed from, with their permission, from Mark van Creveld and Subhash Shuri. So, the content wise it is inspired, you know the right term to use, I am using inspired from these two people. If you go to their website, you will find much better slides. Okay. So, again start with an example that this is again a very basic problem in computational geometry, that you are given a lot of shapes, say convex polygons, and you want to find out whether they intersect or not. If they intersect, you want to find out the intersection points. If you think about this, you can find out application of this simple problem in robot motion planning. There are robots moving around the room and you want to find out whether they will collide or not. If they collide, in which points they will collide, you will take some measures. Image overlapping, whether these two images overlap, where they are overlapping. There are many such applications. It is a basic problem. But when we see a problem from real life, what theoretician does is try to find out a structure in it. What is the core of this problem which makes this problem interesting? Forget about convex shapes. What is the basic shape that you know? Line segments. Right? Suppose I give you, forget about this difficult problem. I give you a set of line segments in the plane, and I would like to find out whether there is an intersection between the line segments or not. If there is intersection, how many intersections are there? What are the intersections between the line segments? These are all pertinent questions. This is a set of line segments given to you, and I ask you that just let me know the intersection points among this given line segments. You have to report all the intersection points. This is question number 1, and depending on the application we may ask you also that I do not care about what are the exact intersection points are, you just tell me the number of intersection points. For example, here it will be 3, 4, 5, 6, 7, 8. Depending on the application, I will either report that there are 8 intersections for this given example, or these are the set of points where the line segments intersects. The problem clear to everyone? Please raise your hand if the problem is not clear. Question is how to find out these intersections. So, her suggestion is that you take any line segment and find out whether it intersects with any of the other line segments or not. If it intersects, you report the intersection point. This is a correct algorithm. But what is the time complexity? N square. Because I took one line and check with all the other n minus 1, n minus 1, n minus 1. This is n times. So, order n square. Can we do better? So, you are saying talking about n minus 1 plus n minus 2 plus n minus 3, this is equals to the AP series. Find out what the summation is. Order n square. That it may be. But if this, it's not if and only if condition. If the slope is different, no, but it's a line segment, it's not lines. Two lines always intersect, but the line segment may not intersect. These are line segments, there is a trick. Otherwise, our problem would have been much easier. So, raise your hand if you think there is an n log n algorithm. Raise your hand if you think that there is no n log n time algorithm. So, this is the naive algorithm that we are doing, taking each segment. Suppose my input is like this. How many points I have to report? There are n by 2 red lines, there are n by 2 blue lines. The colors are visible from the back. How many points I have to report? Order n square. Forget about constant. We are computer scientists. Order n square. So, if you have to report order n square point, is it possible to report order n square point in time less than order n square? You have to spend at least order 1 time to report that each point, right? So, worst case we cannot, it is not possible to beat n square, it is not possible. This is an example where you have to report n square points. How can you report n square points when you are not spending n square time? Clear? But what if my application needs me to only report the number of intersection points, not the exact intersection points? Then I do not have to report all the intersection points, I will just have to report this is the number of intersection points. For example, here I will report n square by 4, the number. For that case, this lower bound does not hold. Also, how we learn, when we learn algorithm, what we learn is that the runtime of an algorithm has to be measured in terms of the input size. N log n for a sorting, n for searching, log n for binary search. What is this n? N is the size of the input, right? N is the size of this input, but is it always necessary to express the runtime in terms of the input size? Can we provide an algorithm whose runtime depends on the input size as well as the output size? For example, suppose I know that any algorithm for reporting all these points will take order n square time, but what if my input is like this? Then I do not have to report an order n square time, but my naive algorithm checking all whether every pair of line intersects or not still will take order n square time, right? In a sense, what we are looking for is a algorithm which takes time order n log n plus k. What is k here? K is the size of the output. When k is order n square, our algorithm will take order n square time. When k is order n, our algorithm will take order n log n time. But for the naive algorithm, it will always take order n square time. This is our objective, but today we will present algorithm which will take order n plus k log n time. That is, when the output size is n square, it will take n square log n time, which is slightly worse than the brute force algorithm. But if the output size is order n, our algorithm will take n log n time. If k is n, then this term will be order n log n. So, I hope that we will not get this skewed kind of input all the time. Most of the time we will get where the number of intersections is of order n, and the algorithm that I will propose will outperform the naive algorithm. Clear? Questions? Any questions till now? Okay. So, let us see. Again, this is a very popular technique among all theoreticians or algorithmic researcher. Then that is, when we are given a problem, most of the time we do not able to solve that problem. But we cannot say that to the world that we can't solve this problem, because we think that we are superior or something like that. We have a taboo like that. What we do is, we simplify the problem and solve it and say that, look, I have done something at least. right? I am sure that most of the human beings does the same thing. So, we have started with the problem with finding a intersection of n line segments in R2, too difficult. What we will try to solve is, suppose we are given some intervals in 1D. On a line, these are the intervals. So, they are not elevated. If I draw all of them in the line, you will not able to distinguish between them. So, I have put them little bit above the line segment. This is all intervals in x axis. This is x1, x2, x3, x4. These are intervals. And the question remains the same, that I want to report all the intersection of this line segments in time order n log n plus k or n plus k log n. Question clear? Please raise your hand if it is not clear. Good. What we will do is, we will create a thought experiment. What is the experiment? Thought experiment. Suppose consider this line. This is called a sweep line. And what I will do, I will move this line from left to right, and I will report the intersection points as and when they appear. There is a sweep line. I will move the sweep line from left to right, and whenever I find the intersection, I will report. This is my objective. But the question is, how do I know that when the intersection point will come? To know that where is the next intersection point is, we need to store some information about the current state of the system. For example, when I am here and the sweep line is here, I should know, about maybe the sweep line is here, I should know that the currently the active line segments which are active currently is S3, S4 and S5. No, sorry, not S5, only S4 and S3. Right? So, I need to store some kind of information, and if you observe this information, like quote unquote this active line segments changes while I move the sweep line from left to right. Initially, when I cross this point, what are the active line segments? Only S1. When the sweep line reaches at this point, what are the active line segments? S1 and S2. When the sweep line reaches here, what are the active line segments? So, the information also is changing constantly, and it is not like a continuous, even at discrete points the information is changing, right. At the point in which the underlying structure of the problem changes, we call those points event points. For example, what is the first event point in this when I am sweeping from left to right? Left endpoint of S1, then left endpoint of S2, left endpoint of S3, then no, right endpoint of S1. Because what happens here? S4 is no longer active. Right? Right? Now you tell me, if I maintain this structure, what I will do, it is like alarm clock. I will put an alarm that at each left point, sort the left points from left to right. I have the input line segments, I can sort the endpoints according to left to right. I will tell the sweep line algorithm to stop at these particular points. And if it is a left endpoint, what I will do? I will insert that line segment into my structure. If it is a right endpoint, what I will do? I will delete the segment from my data structure, right. But who will report the intersection points? How to report the intersection points?
When you are inserting it, so if suppose on the left hand side you are trying to figure out how many are actually
Very good. So,
just like n log n.
so I am in the right direction, I hope, because the answers have started coming from your side. It is a correct answer that you look at any start point. Your data structure will know how many active line segments are done and which are the active line segments. You just report, for example, here the active line segments are S3 only. So, you report an intersection between S4 and S3. S4 is started and S3 has already started but not ended. So, you report the intersection point. So, this is the overall idea of a sweep line algorithm. Is it clear? So, there are two things in a sweep line algorithm: event points, where the structure that I am storing is changing. For example, here the active line segments are changing and they are changing at a left endpoint and a right endpoint. And what else is changing? What else is there? The data structure, that is we are calling the status. The status. This is the overall idea. The left endpoint just report all the pairs Si, Sj, where Sj is a line segment already present in the data structure. And if it is a right endpoint, what I will do? Delete. Why I am repeating these things? Because this is a very important concept that I will use in my future problem solvings. Be careful about this. What is the total time required? Total time is total insert delete time plus total report intersection points. Where we are storing the data, the line segments? We are storing the line segments in a balanced binary search tree. Earlier, we are using numbers to store in the balanced binary search tree. But we can extend that idea to store even the intervals in a balanced binary search tree. Why? We would like to store intervals in a balanced binary search tree so that insertion and delete operation can be supported in log n time. So, this is total is how much time it will take in total? How many endpoints? 2n. At each endpoint, how much time I am spending? Either I am inserting or deleting? Log n. So, 2n log n, order log n. Good for us. How much time this takes? To report the intersections? Number of intersections. The output size. So, this is the total time required to do this whole operations. Are you still with me? Feeling sleepy? Not clear? Should I repeat whatever I have done? Please raise your hand if it is not clear. It is not clear. Which part is not clear? Oh, we can, so what we have done in case of a, so we have a set of numbers. We want to look for a number in log n time. What we do? Balanced binary search tree which supports the operation of insert, delete and query in log n time. What changes when we change that from a number to a line segment? Nothing changes. We can store anything in a balanced binary search tree. That is a data structure. Instead of int variable, what you are using is a struct variable. right? Just using a struct variable. So that insert delete operation can be done. You just numbered the intervals 1, 2 arbitrarily. Now and stored them in a according to their number. That's an integer. Now you can insert, delete, query, log and time. Clear? Clear? Anyone? So it's my duty to make you understand. So don't feel bad if you have a question. Please let me know. Okay, so when reporting an intersection, are we doing any false reporting? That whether there is no intersection but still we are reporting? No. We are only reporting the intersection point when they are intersecting. So I am charging the reporting part to the output size, because I have two components in the runtime now, input side component, output side component. I am charging the insertion delete from the input side, and I am charging the output to the output size. That is why what I am trying to achieve is n log n plus k. This is input and this is output, right? Suppose you have 10 apples and 5 bananas. If I ask you how many fruits are there, you will say 15. How? You can say that 1, 2, 3, 4, 5, you count each fruit and say that 15. Or else what you can do is you can count all the apples and all the bananas and you add them up. So I am doing the same thing. I am dividing the whole runtime into two parts. One I am charging to input and another I am charging to the output. This n log n, 2n log n parts comes from the input, whereas the k parts comes from the output. Clear? Questions? So look, I am very lazy. So if you have understood everything correctly, then I will ask next problem I will ask you to solve the next problem, or at least try to solve the next problem together. Are you guys with me? Let's try to solve together. Okay, let's go. So we theoreticians are not at all that much lazy. We do come back to the real problem eventually. But that's the previous exercise give us some insight to how to solve the bigger problem. So we are back to the 2D again. We have a set of line segments in the plane and we want to report all the intersection points. How to do? I will do it by sweep line. Okay. Okay. Good suggestion again. Is that I will do the same thing. What I will do, I will take the projection to x axis or y axis and do the same thing. But let us see what problem will arise when I do that. So initially when I am here, so this is S1, S2, S3, S4, S5. First I will put what are my event point? Event point is again the start point and end point of the intersection. That has to be the event point. Otherwise, how do I know that there is event point? There are intersection, a line segment and started. Scanning from left to right, and event points are for the time being only the starting and left end point and right end point of the line segments. So, what are the active line segments here? S1. What is the active line segment here? Should I check whether S2 has intersected with S1 or not? I have to. Order 1. What are the active line segments? S1, S2. Should I check how much I am reporting? 0. They are not intersected. S1 has not intersected with S2. S3 is not intersected with S2 and S1. So, I cannot charge this intersection, that time I am spending to find the intersection, to the output size, because I am not outputting anything. So, this will be 1 plus 2 plus 3 plus n. This is the time I will spend just for checking whether the new line segment intersecting with the active line segments or not. And n square time is gone and I have reported nothing. So, how to overcome this? Okay, some hint. So, whenever you are stuck, who helps us to design good algorithms? Properties, right? So, think about a situation at this point. What is going to happen after this point? These two line segments are going to intersect at this point. So, while I am sweeping from left to right, can I claim that before they intersect, they have to be adjacent with each other? So, what is a sweep line? There is a ordering of the line segment in the sweep line. Look at the intersection of the line segments with the sweep line. There is an order among them, right? So, what is the order here? First one is L4, then this is L2, then this is L1, then this is L3. This is the ordering of the intersection of the line segment with the sweep line, when the sweep line is here. What is the order here? L1, L3, L2. Clear? Now, my claim is just before two line segments intersect, they have to be adjacent in this ordering. Before this intersection point, you see that L4 and L2 are adjacent. Take this intersection point. If I just take a sweep line here, L3 and L2 are adjacent. Yes. This is horizontal, sorry, the sweep line. Yeah, this line is a vertical line, right? My bad. Sorry. The horizontal line, the vertical line that I am sweeping. Right? I hope that I have not confused you a lot. The horizontal line, vertical line that I am sweeping, and my claim is that if two line segment intersects, they have to be adjacent before that. Are you with me? Please raise your hand if you are not convinced. So, what is the intersection point? This is the intersection with the sweep line with L2. This is the intersection of L3. This is the intersection of L1. What is the ordering? L1, L3, L2. They are adjacent in the ordering. With respect to the sweep line, they are not adjacent otherwise. With respect to the sweep line, there is a ordering of the active line segments. Because what happens at the intersection? When we reach the intersection point, what is the ordering? They are exactly the same for both the line segments. This point, the intersection of the sweep line with L5 and L6 are exactly the same. Okay, I am assuming that can be handled, assuming that no 3 lines intersect. That's okay, that's not difficult to intersect. I'll report 3 of them. Not that much. But let's not focus on these special cases. Okay? So we have one property, but how to exploit this? Yes?
Just before the intersection, suppose for the first intersection, L3 and L2, for that case, the ordering is L1, L3 and L2. Just after intersection, the ordering got interchanged.
Yes, very good. So what is claim is that after each intersection the ordering sweeps. So it was L1, L3, L2, now it will be L1, L2, L3. Good observation, we need that. Okay, very good. Let's see. What we will maintain? We will store the line segments. Also as a status, we will maintain the ordering of the lines, sorted ordering of the line segments with respect to the sweep line. What we will maintain? The ordering of the line segment with respect to the sweep line. Let us see. What is the ordering here? L1. What is the ordering here? L1, L2. Now there is a possibility that L1 might intersect L2. I will check that whether L1 intersects L2 or not, order 1. If it intersects, I report. What is the next event point? L3, left endpoint of L3. What is the ordering? L1, L3, L2. So L2 is in between L3 is in between L2 and L1. So there is a possibility that L3 might intersect L2 and there is a possibility that L3 might intersect L1. How many checks I have to make? 2. Always 2. Because in a sorted ordering, how many neighbors you can have? At most 2. Right? I will check whether L3 intersects with L2 or not. If yes, report. Whether L3 intersects with L1, no, I do not report. But what we are maintaining is a sorted order of the intersection with the sweep line with the line segments. They can change at a left end point of a line segment and a right end point of a line segment, and where else they can change? As you have correctly pointed out, at the intersection. Now, what the ordering becomes? L1, L2, L3. I will check 2. So 2 neighbors changes, right? There is 2 line segment which sweeps. So this was that. So after this, what will happen? Suppose this is L1, this is L2, this will become L1, this is L2. What I will do? I will check whether L1 intersects with Li and I will check whether L2 intersects with L3 or not. How many checks? 2 checks. Constant. I am happy. And I will go on doing this. Still with me? Should I repeat? So, these are the event points, left endpoint, right endpoint and intersection. Where to store again our whole friend balanced binary search tree. We will store everything in a balanced binary search tree and insert delete everything in log n time. Even for the intersection with the sweep line, we also maintain in a balanced binary search tree. Okay? So, what we will do here? I am inserting L6. Once again I will repeat. Who are the new neighbors of L6? L4 and L3. What I will do? I will check whether L6 intersects with L4 or L3 or not. If intersect, report, otherwise do not do anything. Okay, what is the next intersection point? Next is a right endpoint of a line segment. So, when L6 got deleted, if I move the sweep line right, L6 will not be present, right? When the so which are the new two neighbors? L3 will becomes a neighbor of L4. Previously L3 was not a neighbor of L4 because L6 was in between. So, while deleting L6, I will check whether L3 and L4 intersects or not. Right endpoint. This is my event point. Right endpoint, I am checking whether L3 is intersecting with L4 or not, because after L6 being deleted, L3 and L4 will become neighbors. So, there is a possibility that they might intersect. I will check. And there is an intersection, what I will do? I will sweep and I will do two queries, this Li, Lj, whether they will intersect with the new neighbors or not. Li will remain a neighbor of Lj, Lj will remain a neighbor of Li, but they will get, each of them will get a new neighbor. I will check with them. Clear? So, at each event point, how many updates? At most 2. How much time it will take? Log n. What is the total number of event points? 2n, left endpoint, right endpoint plus k intersection points. Order n plus k, each taking time, log n. So, together the whole time I will take is n log n plus k log n. N plus k log n into log n, that is n log n plus k log n. Doubts? Oh, that is n log n I will spend in the beginning. So, construct the first sorted order will take n log n. What I will do? I will put a balanced binary search tree and ordering of the line segments. Right? I will put how much time it will take n log n to construct the balanced binary search tree? Tell me. Yes, yes, yes. What I am doing is, I am putting the lines, active line segments in a balanced binary search tree, right? According to their sorted order along the sweep line. Oh, initially what is the sweep line? Yeah, so only L1, right? Next it will become L1, L2. L2 is an entity. Now, what I have done in the previous case, what I said was that to insert and delete, you create a name for each line segment, S1, S2, S2, and insert or delete accordingly. but here I am inserting or deleting according to their position in the sweep line. I will not shift, I will just sorted the event points. No. It's a concept, it's a vague concept. We are not constructing, this is a thought experiment. What I will do, I will stop at the event points and update the data structure. There is no sweep line as such. It's all in our mind. There is no sweep line. At event points, what are the event points? Left endpoint, right endpoint, and intersection. We'll update the data structure. And from the data structure, we will find out whether they intersect or not, whether there is an intersection between two line segments or not. But as if the data structure works as if we are moving a sweep line across the plane.
What if that's a vertical line?
Okay, good question. You tell me. This is my axis, y-axis, x-axis. I tilt it a little bit. If I tilt it, then there is no horizontal line. I will make the transformation for all lines. There are n lines, order n time. And you can always find the angle at which if you tilt, there is no horizontal or vertical line. You understand what I am saying? It's a like the axis is like a x-axis, y-axis is a concept. There is no x-axis, y-axis in a real time. Just tilt it. So these are degenerate cases. Like for example, he asked that what happens if there are 3 lines going from the same point? You tell me what to do. Small tweaks in the data structure can fix these things. They're not. So I think I'll stop here. I am not done with the sweep line. Yeah, but I'll not start with a new problem because we have only 15 minutes. Tomorrow we'll start with a new problem and then move on to inserting. Is it okay? Please let me know. I have 15 minutes time. Please let me know if it is okay. I'll go through once again to brush up all these concepts. This is a thought experiment where we are moving a line from left to right. And depending on certain events, we are doing something. That's a very common concept in a computer. We schedule tasks depending on the time, right? Suddenly you are doing an important thing and then there is an update coming up. How Windows knows that there is an update has to be done now? It's just stored with a pointer that this has to be done in this time. If you think about how it is implemented, the same thing. I have maintaining a list and I am processing one by one. And I am changing the list dynamically. Some events are being added, some event has been deleted, and depending on that, I am processing the whole data. At each event point, what I am doing? I am making some changes to the data structure. What are the changes I am making? If it is the left endpoint, I am checking, I got 2 new neighbors, maybe one, you have in the last or first line, whether the new line intersects with the 2 neighbors or not. If I am deleting, then 2 lines which are not neighbors before now become neighbor. I will check that whether they intersect or not, right? And if there is an intersection point, I know there will be a change in the ordering of these 2 lines. These 2 lines each will get a new neighbor and I will check for that whether there is an intersection between new neighbors or not. So only I am working in the event points, and each time I work in the event point takes log n amount of time. Maybe 3 log n, maybe 4 log n, but I don't care. It's order log n. So total number of event points is n plus k, or rather 2n plus k, order n plus k, into each event point I am spending time log n. So altogether I am spending n plus k whole into log n. See, this is not a difficult concept, it's just a new concept. Think about this, is a very easy concept, but it's a new concept, new way of thinking about algorithms. Please raise your hand if you have a question. Yes, ma'am. Oh, how do you insert a number in a binary tree? So there is an ordering here. While inserting, you know that this line has to be inserted between L3 and L4. So you know the ordering of these lines with respect to the sweep line just before that. Oh, sorry, not this one. You know the ordering of the lines here. That's the thing that you are maintaining, right? Now you are at this point. Can you consider this as a y-axis? You know the intersection point or the value, an integer value of this intersection point, right? You can pre-calculate this intersection value, this intersection value, this intersection value, this intersection, this sorted order you know. What I will do? I will check this line. I know that this line is in the middle, right? I will find out its y coordinate, means this line where it intersects. Suppose this is 10, this is say 5. So I know that I have to search in this part. Which are the lines in this part? This line and this line. I check with this line, this is above. I check with this line, this is below. These two are adjacent. Hence, this line has to be inserted here. Just the same binary search. So if you have functions f1, f2, f3, fk, right? Now I want to insert a function f star. How to insert? I know this is a sorted order in x axis. How to insert? For the x value, I will calculate f star x and take the fk by 2 x. If it is smaller, I go left. If it is larger, I go right. Same as binary search. And I will continue till I find the right position to where to insert. These lines are nothing but the functions. So that's why I have not started with the example of integers. Binary search is not limited for integers. There can be binary search in many places. The question is, can you throw away half of the input? If you can throw away, depending on something, you can throw away half of the input, then you are good to go for a binary search. Just maintaining the sorted order of these functions. Clear? Is it? Yeah. Two values are changing. In this ordering, two values. So I will do 2 deletion, 2 insert, 4 log n. Right? Or constant, many values are changing. That's my point. And constant, we don't care. We are computer scientists. Delete, insert. How it will get balanced again, not my concern. That the previous data structure that I have mentioned, that will take care. Insert, delete with balanced, it's order log n. So, okay, so let's close it for lunch.